Hi, welcome to Real Learning Center, and this is the fourth video of the series called as motion. So in the first three videos we talked about how motion is relative and there is nothing called absolute rest, and we also talked about the difference between distance and displacement. We talked about the concepts called scalars and vectors in that, and in the third video we talked about speed and velocity. Now in this video we are going to talk about acceleration. So acceleration is a concept, it is a little harder to understand in the beginning. Though you think you understand, there will be a lot of nitty-gritties in that. So let's focus and see in detail what is this acceleration and how do we calculate and how do we measure and what is the unit and all that. Okay, so let's start with basically understanding and getting a feel of an acceleration first. So I want you to watch these two cars. Okay, so they actually one of them moves with constant velocity, another one moves with acceleration. So you tell me which is which. Okay, okay, the first one actually moved with constant velocity, second one picked up velocity and it is accelerating. So we call accelerating. So whenever there is increase in speed, we call it acceleration. Let's start with the first understanding. Whenever you are increasing the speed, you are accelerating. So in a car or a bike, in a bike you accelerate. In a car you press your accelerator pedal and you accelerate, you increase the speed. So the word acceleration, accelerator comes from this word acceleration. Okay, whenever you are increasing the speed, you are accelerating. So that is not the only scenario. Let's take another scenario. You saw now actually two cars went by. One of them actually went straight. The other one went up and down. Okay. Both of them actually were going at constant speed only. But going at up and down is also actually called as acceleration. So speed may be same, because speed is not changing at all over time if you see. So going up and down like this is actually called acceleration because there is something changing there. We'll see what is changing. Okay, speed is not changing. And not only that, take this scenario. This pickup truck actually is going around in a circle at a constant speed, no change in the speed, but it is moving in a curved path. If you move in a curved path, then also we say that it is getting accelerated. It is acceleration. So moving in a curved path is acceleration. So now, what else? Is there any other thing is called acceleration? Yes, let's take this scenario. So you could see that one car went fast without slowing down. Other car actually slowed down. See again if you want to. Okay. So one car went very fast and the other car actually slowed down. Okay. The car which slowed down we call is getting accelerated. So decrease in speed also is acceleration, not just increase in speed. So decrease in speed also is acceleration. So now let us see what are the things that kind of summarize things that we saw. One, we saw increase in speed with an acceleration. Going up and down like this is acceleration. Going in a curved path like this, acceleration. Slowing down, acceleration. Okay. I want to actually, instead of saying those four things, I want to say it in a much more simpler way. Okay. I'll use only two statements to say it. If there is change in speed and or change in direction, then we say that the object has some acceleration, even if there is a change in speed or if there is a change in direction. So slowing down and speeding up, both of them come in the first line. Change in direction, which is going up and down like this, direction changing, once like this, once like this, and curved path, changing the direction all the time, that comes in the second line. So these two lines now summarize the whole thing. then we say it is having acceleration. So there is one more way, one more optimization possible. Okay, we are saying that change in speed or change in direction. So speed and direction basically put together, we realized that in the last class a new word we introduced, and that was called velocity. Velocity is both magnitude and direction. Any one changes, velocity changes. So instead of saying speed changing or direction changing, we could simply say velocity change. So if there is a change in velocity, then we say that there is some acceleration. Okay, if velocity, that's all, one single statement. If there is a change in velocity, then there is some acceleration. But when I say this single statement, I have in my mind change in speed and change in direction. When I say change in speed and change in direction, I have in my mind those four. Okay, so you can't forget them. They are just summarizing that and putting it in short form. Change in velocity. Okay. Now, the question is how much acceleration? Till now we said there is acceleration. How much? Okay, there is, but it may be less acceleration, more acceleration. How do we measure that? So watch this A and B both. Okay, both are actually getting accelerated, but one of them is accelerated more. Okay, the other one is accelerated slightly less. So we need to ask questions like, for example, how much is car A's acceleration? How much is it accelerating? Is there a number to that? Or simply say it is increasing the speed. How much it is increasing the speed? Is it increasing the speed very fast or very slow? How much is car B increasing the speed? What is its acceleration? So we may say how much more is car B's acceleration when compared to car A's acceleration. So how do we measure acceleration? What is the unit? So these are the questions that we have to answer. Okay, because in physics we talk about quantities. So everything when you talk about, we talk about how do we measure, how do we define, how do we calculate, we have to say. Otherwise it is art, it's not physics. Okay. So in physics we go into trying to understand how do we measure this and how do we calculate this once you talk about acceleration. So let us see. I will say acceleration is nothing but rate of change of velocity. That is the statement. What does it mean? We will come to know. Okay. Now I have put here two different cars. One car is supposed to be going with constant velocity. The other car is accelerated. I have put both because while seeing you will be able to appreciate it, that which one is accelerated. Okay. So let us say at time t is equal to 0. That means in the beginning of time. That's mean whenever we start looking at that time. That is called time t is equal to 0. Maybe a stopwatch will start. Okay. Then this thing stops moving. The first one is moving with constant velocity. The second one is picking up speed. Okay. So accelerating. So it accelerated and gone. Now, I'm going to find out how much it accelerated. How do I find out? So I will actually choose 2 points. Okay. So these 2 points, I will say one of them is basically after 1 second from the beginning. That is t1 is equal to 1 second. That means my stopwatch has said 1 second. And then t2 is equal to 3 seconds. At some point in 3 seconds. Now what I want to do is I want to measure how much is the acceleration in this area. Okay, in this area, what is the acceleration? Let's define the acceleration in this area. So how do I do that? I actually start with basically looking at the speedometer. Okay, speedometer in this area is showing me some value. Okay, let's say 20 meters per second. So my speedometer is showing in meters per second, not kilometers per hour. So this is 20 meters per second. I will call this, I will actually keep increasing the speed because you saw that it is increasing the speed, and then you see it is around 40 meters per second. Okay. So speedometer here is showing one reading, speedometer there is showing another reading, and it has increased during that time. Speedometer is kept going like this. So the first one I call as, for this duration, if I take this duration, first one is called initial velocity. The other one is, last one is called final velocity. For that duration, there is even more. If you consider some other duration, initial velocity will be different. For this duration, this is initial and that is final. So now, this initial velocity, we will call it as u and final velocity v. Those are the some symbols that we use, okay, just to make sure that you don't keep writing long things. We write simply u and v. Now what we will do, we will actually now define the acceleration. Acceleration is nothing but rate of change of velocity. What is the meaning? That means change of velocity divided by time duration. So whenever we write divided by time duration, we say rate of change. The word rate of change is used when we put a time duration in the denominator. So rate of change of velocity is nothing but change in velocity divided by time duration. So let's now find out how much is that. Okay. So we will say that change in velocity is how much? Final velocity is v, initial velocity is u. So it is v minus u. Okay. Final time is t2, initial time is t1. It is t2 minus t1, time duration. Or we could say v minus u. I am going to call t2 minus t1 as another value t. The duration I will use the word t. So what we got now is this acceleration, which we are going to give a notation of a, okay, is nothing but v minus u divided by t. So we have to now basically write down these values. What is v, what is u, what is t. Okay. V we know. V is speedometer is showing v is 40 and u is 20 and t is 2 seconds. So 3 seconds minus 1 second is 2 seconds. So all these three values we know. So we can actually substitute it. So 40 meters per second minus 20 meters per second divided by 2 seconds. So once you substitute that, 40 minus 20 is 20 meters per second. And in the numerator 20 meters per second, denominator is 2 seconds. So we will divide it and get the answer as 10 meters per second square. I wrote the word second square because there is a second there in the numerator. Denominator of numerator, meters per second, and denominator one more second. So these 2 seconds multiplied together will give second square. So what does it mean? We'll see. Okay. So meters per second square is the unit of acceleration. Whenever you want to specify acceleration, you have to say meters per second square. When you specify length, you say meters. When you specify velocity, you say meters per second. When you specify acceleration, you say meters per second square. Like, okay. So now what is this 10 meters per second square? What is the meaning of that? So let's understand the meaning of that. Okay. Now actually what happened from T1 to T3, the car actually accelerated, bottom car you can say. Okay. When it accelerated, you got u to be 20 and v to be 40 and t to be 2. Okay. So what did we do? We said that we calculated the acceleration to be 10 meters per second square. What does it mean? That means 10 meters per second. What it means is that velocity changes 10 meters per second in every second. Every second 10 gets added to the velocity. 10 meters per second gets added to the velocity after every second. So initially look at this point where at T1 it is basically 20 meters per second and at T2 it is 40 meters per second. It is totally 2 seconds. Suppose if I take it in the middle now, after 1 second from the beginning, what would be the speedometer reading if you want to find out? Okay, you can think. So every second it is going to add 10. So after 1 second from the T1, that is at t is equal T1 is at t is equal to 2 seconds. If you take speedometer reading will be how much? 30 meters per second, because 20 plus 10, 30 meters per second. If you want to take in between that, okay, so then in between that again it is half a second. For half a second it is 5 meters per second. So you can say here it is just how much you will get? Basically 25 meters per second. And there if you take, for example, after that you will get about 35 meters per second. So like that, once you have the acceleration, you can calculate velocity at any point. Okay. So that is what is the meaning of 10 meters per second square. So now, what if it slows down? We only talked about when it goes fast. Now it increases the speed. So let us say when it slows down, the bottom one is slowing down, actually you can see. Then what happens? Then actually velocity has decreased. I am just giving this notation to show you that it is decreased. Okay. So now when the velocity is decreasing, we will use the same formula, a is equal to v minus u by t. But unfortunately in this case v is u. V is u and u is v. Like 40 and 20 got interchanged. So we will say 20 meters per second minus 40 meters per second divided by 2 seconds. That would be basically nothing but minus 20 divided by 2. So minus 20 divided by 2 is minus 10. So minus 10 meters per second square is the acceleration when it is slowing down. So whenever it slows down, acceleration is negative, okay, when it is slowing down. So there is one more word for that, okay. So we call that as deceleration or retardation whenever it's slowing down. When you apply brake, this is what happens, okay. So now we have kind of understood what acceleration is, okay. So we are going to now basically formulate our first formula in kinematics. Kinematics means, where in physics we have these two parts called kinematics and kinetics. In kinematics we talk about velocity, acceleration and all that, but we never talk about how one can accelerate it. We don't talk about the forces and all that, okay, just acceleration. So this is our first kinematics formula. So how do we get that? We already know, okay, we already know a is, we calculated to be, we discovered a is equal to v minus u by t. So it can be written as basically at. Now t you get it this side, you call at is equal to v minus u, or you could say at plus u is equal to v. Okay. So if you invert it and write it, you get v is equal to u plus at, and this formula is considered to be one of the most fundamental formula of the kinematics, and you will be using this formula forever, okay, when you keep learning physics. So remember this v is equal to plus a. I mean, it's not very needed to remember. If you know how to find out a is equal to v minus u by t, concept of acceleration will help you with this. So there are still some questions to be answered. Okay, we have answered a lot of questions regarding acceleration, but there are some left unanswered. So what are they? The first one is, so in velocity we talked about average velocity and instantaneous velocity. Is there such a thing in acceleration? Average acceleration and instantaneous acceleration. That is the question we have not answered. Okay. So there is. Now there is average acceleration and instantaneous acceleration. And how do we measure that? What is the definition? All that I am not going to basically discuss in this video. It will happen in future videos. And what happens when acceleration changes? Can that happen? We said that when velocity changes, you say rate of change of velocity is acceleration. But if acceleration changes, what is rate of change of acceleration? That's an interesting concept. So that will also postpone it. Okay. And then finally, we said that acceleration occurs not only when speed changes, but when direction changes too. So when direction changes and speed is not changing, how are we going to calculate this v minus u by t? Okay. So how do we do this work? So this requires vectors. So that again we are going to postpone and talk about this kind of acceleration a little later. Okay. So now we have actually covered almost all the topics that we wanted to cover. Okay. Motion is relative, distance and displacement, speed, velocity, acceleration, everything. So this set of 4 videos will give you a basic framework to understand the whole of physics actually. So enjoy learning physics. Thank you.